Hello, my name is Ian Sierra, and this is the Lab 5 video report. The purpose of this lab is to investigate and model any system that I choose. I have to obtain data from an observation, use at least one physics model, and use glow script to model my findings. I decided to analyze the following motion of two objects: a sheet of printer paper with a small mass and a stack of numerous binders and folders that have a larger mass. I want to compare the difference in the effective drag force between an object with a small mass versus an object with a large mass. I also want to use the energy principle in order to model when terminal velocity is reached for each object. The concepts of weight force, turbulent drag force, the energy principle, and Newton's second law are used in this lab. In Tracker, I analyzed the motion of both objects falling. I had to set up the orientation of the axis to be in line with the motion of the falling object in order to obtain a downward sloping graph, as you see right here. And the origin is at the center of the object at the beginning of the video. You will see the stack of binders fall to the ground. The falling motion generates a line graph that shows a downward sloping graph that at first starts going down gradually and then becomes steeper as the binders continue to drop. A noticeable difference that is seen between the binder falling and the paper falling is that it takes much longer for the paper to reach the ground and it does not fall perfectly straight down. I created a separate code for the falling paper and a separate code for the falling binders. And we're now looking at the code for the falling binders, and the code between the two are pretty much the same except for a few specifics. In the codes, I had to specify the mass of the object and a small time step. Values for acceleration due to gravity and J hat are also defined to calculate the weight force. I had to find the proportionality constant B, which was found by running the model and matching the final position in the model with the final position in Tracker. And this is a drastic difference between the proportionality constant of the falling paper right here and the proportionality constant of the falling binder. I also computed the system energies of kinetic energy, gravitational potential energy, and the total energy. In the loop, initial energies are defined. The weight force and turbulent drag force are used to calculate the net force. Newton's second law and the final position formula are listed in order to update the velocity and position of the object, and the energy changes are also calculated. When the model runs, an illustration of a falling object is displayed, which shows a orange arrow, which represents the gravitational force, and a cyan arrow, which represents the drag force. Also, a change in energy graph and a position versus time graph is shown, and we will analyze these graphs more by comparing the falling binders versus the falling sheet of paper. The change in energy graphs are generated by glow script for the falling binders and the falling sheet of paper. They both start off with positive kinetic energies shown in blue and negative gravitational potential energies shown in red. The kinetic energy eventually becomes constant at zero, and the gravitational potential energy becomes constant at some negative value. The instant where the kinetic energy becomes zero indicates where the object reaches its terminal velocity. And if you look at the formula for change in kinetic energy, the final and initial velocities will be the same, meaning that the change in kinetic energy will be zero. And the model shows that the falling paper reaches terminal velocity before the falling stack of binders. When observing the position versus time in a separate spreadsheet, I plotted the experiment position for both falling objects and the model position for both falling objects. As you can see on the graph and also saw in Tracker, the sheet of paper takes longer to reach the ground than the stack of binders. My experiment positions for both the binders and the sheet of paper are slightly off due to human error in Tracker. When looking at the model positions for the binders in yellow and the paper in green, it shows that the paper reaches a terminal velocity earlier than the binder, where the binders have to fall a little longer in order to reach the terminal velocity. In conclusion, the data from this lab shows that drag force causes an object with a smaller mass to reach terminal velocity faster than an object with a larger mass, which was represented by both the plotted graphs in the spreadsheet and the modeled change in energy graphs. Some errors that could have an effect on the results of the lab include the fact that the paper fell for a longer period of time than the binders, which could have an effect on how the data can be observed, and the way that I plotted my point mass and tracker, which could have been slightly off. Thank you so much.